Hello everyone, welcome to Linked Frequency. I'm Vaibhav Sugandhi and in this particular tutorial I'm going to talk about exploring Tinkercad. The entire course which we designed Arduino for absolute beginners for 2021 and also 2022, it covered more than 13 to 14 tutorials. This is going to be a 15th one which focuses more on learning Arduino for the first time with the help of Tinkercad. We started with introduction to programming, understanding the basic terminologies in electronic circuits and also understanding some terminologies with respect to programming, and then we headed towards learning the instructions, and then we started with LED blinky program for the first time with the Tinkercad. Now we are at the end of the entire tutorial, in fact the entire course, and I personally believe that you understood the entire protocol. However, now we are heading towards exploring new things with respect to Tinkercad. I'm going to show you some sensors which we have not used previously and also some of actuators which we have not tried before. And also I'm going to show you a couple of extra features which are provided with the Tinkercad which you might not came across so far, but we are going to explore them with curiosity. Without further delay, let's get started. Alright, you can see a screen in front of you and of course we have little bit complicated circuit. It's not a circuit, by the way. Why? Because I have not integrated every component which you are seeing right now in front of screen with respect to microcontrollers or maybe Arduino development board that I have used in the screen. Just couple of them are integrated and even the code is written for couple of actuators and sensors, not sensors actually, only actuators, just to showcase you how exactly we can use this combination. So first of all, we are going to explore new things with respect to Tinkercad, and then we are going to head towards running this particular program and showing you how exactly they behave when you are using them for the first time. So first of all, you can see that all these components are familiar to you because you already know that how to change from basics to all, and you can explore all of these components. What if we can get some new detail or maybe a basic information about these components before using them? That we can do by toggling or maybe clicking on this particular icon which is located at this point. Hope you are following my cursor with a mouse, and you can see that when I click on that particular icon, you can literally read a couple of sentences with respect to that particular component or maybe device that you are using. Say for example, if I scroll down a little bit below, you can see that inductor is written as a resist change in current flow. That is a general information with respect to any component that we are looking in Tinkercad. So this is going to help you when you are designing a circuit for the first time and wondering what to use to achieve whatever the desired result you are expecting. Say for example, you are looking for an on-off switch. Which kind of on-off switch you need to use, and what should be the definition for on-off switch? If you don't know, then you can always look at slide switch definition or maybe the small description written in Tinkercad. So this is a first feature which you must remember, which you must understand with respect to Tinkercad. Back to normal because I just wanted to see it, however I want to use every day. And when you scroll down a little bit in a sensor section, which is all about input section, there you can see a lot of components are located which we have not tried so far. But for the sake of simplicity, I have dragged and dropped them on the breadboard which I am using right now to showcase you how exactly they behave and how to use them in reality when you are started with a simulation. So of course I'm not going to integrate a circuit and write a code for that and showcase you each and every component, because I believe you already understood how to do that by yourself with all the previous tutorials, and I want you to do it by yourself without having a dependency on instructor. However, I'm going to show you how to utilize them and how to tune them for your particular application. Thereafter, we can scroll a little bit down and we can see that we have output section, which is all about an actuator section, where you can see these NeoPixel LEDs are located in a large quantity. Various types of NeoPixel combinations are kept here. There is something called jewel, there is something called ring, and there is a larger ring and the larger ring, and even there is a strip of LEDs are located. I don't know what is the reason Tinkercad promote these NeoPixel LED strips so much, but however, I just wondering if it is helpful for you if I do something with respect to NeoPixel LED. So that's why I integrated 4 LED strip as well as a single LED on this particular breadboard to showcase you how exactly we can use those NeoPixel LED for DIY project. Thereafter, I have built a small power supply section here to showcase how you can use multiple breadboard in a single circuit. Of course, it is not recommended to use multiple breadboard until and unless the circuit is large enough that it cannot fit into a single breadboard. But I don't think so. There is such a circuit which is not sufficient to fit into a large breadboard if you are doing it for the first time. But still, if you are exploring a little bit extra things and you still want a little bit of area or extra area, then no problem, you can always use extra breadboard. There is no restriction on that. Not only to that, if you scroll a little bit down, you can see some of the other components like power section and microcontroller section and some other sections like instruments and ICs. All those things are there. In this microcontroller section, you can see there is something called Attitiny, which is Atmel product, and this is a microcontroller. It is a 8-bit AVR microcontroller. I think we can toggle this one and we can search for Atmel Attitiny. Where it is? Here it is. So you can see that Arduino compatible Attitiny 254585 with a 512 bytes of RAM. So this is a tiny microcontroller which is having just 8 pin and doesn't need external crystal oscillator or any other circuitry to run by itself. And it has a limited GPIO, of course, only having a 8 pin, and within that 2 pins are meant for power and remaining 6 pins are GPIO. So I have demonstrated how to use that one here. You can see that Attitiny is located here, and VCC pin is power pin is connected to VCC, and ground pin is connected to ground potential of the entire circuit, and one of GPIO, which is a PB0, is connected to resistor, and then LED in an active low configuration, and we are trying to blink that particular LED by writing the code to this particular thing. Of course, you can ask a very simple question to me: without having a USB to UART converter, without having any programming device, how this particular controller is getting programmed? That is the beauty of virtual simulation. This Tinkercad software is designed in such a way that whenever we write a code in code section with this toggle, you can see that there is option for Attitiny and there is option for Arduino Uno R3. And when you are writing a code for Attitiny, you need not to connect any circuit that converts this code into some understandable language for the microcontrollers, because software does that activity at the back end, and you can simply simulate it. But when it comes to reality, when you're developing circuit by your hand on breadboard and real component and all, of course you need a USB to UART converter which is connected to your computer, and the RX-TX pin is connected to respective pin on Attitiny, which helps you to program that particular microcontroller whichever you are using. But of course it is not a development board, and you have to rig up the circuit and you have to take care of power supply and everything. You must understand that one before conducting an experiment in reality. However, right now we are not more focusing on only one component or maybe a physical part of the entire experiment. So this is one part of the entire story, and thereafter you can see that I have connected a voltmeter just to monitor what is the voltage coming to these trails, and also I have built a power supply which is converting 9-volt battery voltage into a 5-volt which is required for us to run all these peripherals. Of course, I'm not running all those peripherals, but most of them work with a 5-volt potential, so that's why I have built 5-volt power supply. If you want, you can build a 3.3-volt power supply as well, but right now I believe 5-volt power supply is going to be the best one. So after doing that, I have kept couple of sensors and actuators just for the demonstration purpose. When we are simulating, I just wanted to show you how exactly they behave and how you can tune them according to your requirement, so that you can use them however you want in a later stage. Of course, along with Attitiny microcontroller, I am using Arduino Uno development board, not a microcontroller. I hope you remember that particular sentence I quoted in the beginning of the entire tutorial. Arduino is not a controller nor a processor, it is an development board. And this particular development board is going to help you to conduct experiment with respect to the microcontroller within that development board, which is Atmega 328P. So we have a Arduino Uno development board. Along with that, we have a microcontroller which is Attitiny, and you still manage to run both code at a time with a different coding platform. You can see that now I'm visualizing Attitiny code. If I toggle this one to Arduino Uno R3, you can see that there is Arduino Uno code. So this is a beauty of Tinkercad, which I have not discussed in the entire previous tutorial. That's why this tutorial is going to be a special one, and it is going to be exploring Tinkercad more often than executing some circuit or a program or anything. Okay, so let me close the code part and let me focus on the peripherals which we have placed on this particular breadboard. You can see that there is a tiny ceramic capacitor which helps to avoid high frequency noise in the entire power supply, which I just placed with a sense of keeping our supply very smooth and very straightforward for all the peripherals that we are connecting. Okay, and thereafter we can see that 4 strip neopixel LED is connected, and a single LED is also connected, neopixel LED, which works on the single line peripheral. And thereafter we have this ambient sensor and light sensor, IR sensor, tilt sensor, temperature sensor, photo transistor or a photo resistor, we can say, not transistor, it is a resistor. And then we have another tilt sensor which is not having any control over, but still we are placing it. And then we have PIR sensor, ultrasonic sensor, and 555 timer IC. So all these things are kept here. Along with that, of course, we have a flex sensor and force sensor, as well as we have a vibrator here, and then we have a 16x2 LCD display. So of course you can see that none of them are connected to any voltage or maybe a GPIO of Arduino development board or maybe our Attitiny controller, nothing. Just to show you how exactly use them in reality, I'm just placing them on a breadboard and trying to simulate the circuit and showcase to you how exactly they work. So let me start simulating the circuit, which is the most important part, and let me click on that. And you can see that the output voltage is going to be a 5 volt, of course, and this 9 volt battery is giving a 9 volt to this 7805, and it is converted into 5 volt. Thereafter you can see that a little tiny microcontroller, which is Attitiny, is executing its program. It's turning on and turning off this LED just because of internet speed and everything. It is glowing like this and glowing off like this, but actually my program is to just blink it. I don't know what is happening with my computer and internet part. It is doing like glowing part and all those things, which we are not intended, but that is what happening. Thereafter you can see that from Arduino Uno development board I have connected one small LED here just to showcase we can integrate both the circuit and run both the code at a time, like Arduino Uno development code and as well as Attitiny code. So this particular LED will turn on and turn off for the first time, and thereafter these neopixel LED start shifting green color. Of course it is started shifting here, and then shifting to this one. Along with that, this particular neopixel LED will be on all the time. That is how the code is written, because this is having a single LED wherein I have connected that single LED with a 4 strip along with that, because of which it is turning on all the time. So along with that, you can see that when I zoom in a little bit and when I click on this ambient sensor, you can see a cursor here. This is the important point. That is the reason why I wanted to show this particular demo to you. Whenever you connect this specific sensor to your microcontroller or maybe Arduino Uno development board, how do you check output? What is the condition? If I want to give a condition, when light intensity is this much, what is going to happen if you have written that kind of a code, or if you have executed such kind of a circuit, then how to change the intensity and how to test that particular sensor? That could be done by using this cursor. When you click on this particular component, that cursor appears to you. Just by clicking on the start simulation, it will not appear. Do remember this one. When I click on that particular sensor, you can see that particular cursor appears to you. When I click back to that particular component, it goes off. Or you can say that when you click outside the breadboard or outside the entire circuit, it goes off. So make sure that when you are tuning these particular sensors, when you are testing them or when you are using them for the real time, then you must click on this and then change the intensity or change the setting to test your condition. And of course, not every sensor has that kind of intensity setting. Most of them are there, but not everything. Okay, even we can see that there is a tilt sensor which has this cursor, which by changing so you can read a different data from that particular component. And let me check with respect to a temperature sensor. Of course, you can see that temperature sensor is by default to 25 degrees Celsius, and when I change it, it is going to change from, I think, minus 40 degrees Celsius to 125 degrees Celsius. That's amazing. So by doing so, you can conduct your experiment in Tinkercad itself, and you can literally verify your condition, whether your code is working properly or not. When the temperature is this much, whether my code is working. When the temperature is this much, whether my conditions are getting executed. Those things you can verify by doing a small simulation in Tinkercad by using this particular feature. Thereafter, let me check with respect to photo resistor. Of course, it is having certain thing here. I mean, by changing this cursor, you can change the resistance of that particular component. That's why it is so called photo resistor, or maybe a, whatever it is, photoresistor we call it as. Okay, and thereafter we have a PIR sensor. Let me click on PIR sensor, and you can see that when we click on PIR sensor, this particular thing comes in front of us in the screen. It has very good coverage area where you can move this object, and when you are moving this object, you can see that the PIR sensor is detecting that particular object. That's how PIR sensor works, actually, passive infrared, right? And when you are not moving that particular object, it is not detecting anything. Okay, so it is mainly used for motion detection. So when you are making a movement with respect to this particular object, it is making some purple color light is coming out of it. It looks like such kind of a cute response from this particular sensor. But you can notice that, I mean, when I'm moving this object, it is keep on having that pink color response on this particular duct. But when I'm not moving this object, it is not doing anything. Similarly, with respect to ultrasonic sensor, you can always tune with respect to the distance. You can see that there is a change in distance. When we click on that particular sensor, you can always see that the change in distance with respect to a change in object position. Like that, you can read the data and you can explore. Along with that, even with respect to these sensor, which are so called flex sensor, have wonderful response. When I'm pressing down the cursor, I mean, when I'm hitting down the left key of my mouse and changing the vertically, I'm changing my cursor, you can see that the value of this degree, which is a flexible sensor, how much flexible material is, you can literally sense by using this flex sensor. Okay, not only to this one, you can even see with respect to a force sensor. If I increase the force, you can see that the 1.38 Newton force is applied on this particular sensor. I really don't know how this particular sensor works in reality, but I'm pretty much sure this kind of sensors are available in market, and you can literally use them for DIY project. And in Tinkercad, of course, you can realistically simulate something with respect to these cursors available here. Okay, so not only to that one, you can even see that a little tiny vibrator here. When I connected it with a power supply, it is vibrating continuously, and it looks very amazing. I mean, the same vibrator which we are having in our mobile phone and all, right? Those little tiny gadgets that we are using, which they vibrate when some notification comes to you. The same vibrator it is, right? Maybe the size is big one, but yeah, it is nothing but a vibrator. Okay, and of course we have a 555 timer IC here, which I have not connected to anything, but I recommend you to explore with respect to all digital ICs given in Tinkercad, so that you can get to know how to use this particular platform at the maximum possible potential, or maybe you can say maximum possible ways that you can conduct your experiment. Okay, and of course we have a 16x02 LCD, which is going to help you to display something on the project in DIY segment when you are developing any project. So these are the variety of sensors and actuators available with the Tinkercad, and I hope you are going to explore them with a couple of experiments that you are going to conduct after this particular tutorial. Now I want to show you something even more better than this one. Of course, I know that you are already overwhelmed with respect to all the features that we are showing right now, but do remember there is still more things to go ahead. If you are a beginner and you are not aware of how the electronic systems are designed, or how the schematic looks like, or circuit diagram looks like when you are building a circuit like this, then no worries, you can always click on the small icon here, which is a schematic view. The moment when I click on that, it will convert your design into a circuit diagram that you have never seen before. I think you can see that some of these connectors are, I mean, the ICs are not connected because I have not connected or I have not built any circuit for them, right? So but when it comes to Attitiny, you can see this. With respect to Attitiny, it has some wire connection, it has some LED here, resistance and motor, everything is connected here because I have connected a circuit. I have built a circuit for Attitiny, because of which it is showing some circuit diagram. So this is nothing but a circuit diagram, or you can say a schematic, and it is not so professional, by the way, but you know, for beginners, this is going to help you to understand how circuit diagram look like. And not only to this one, even if you go to this particular option here, which is a bill of material or maybe a component list, you can see that designator of the component, or we call it as a designator in an engineering term, but in this case it is named as, I mean, it is so called as a name. And then we can see a quantity and a component, what kind of a component it is, or maybe a little description of the component. You can see that the UN is Attitiny IC, R1 R2 R2, quantity available with 100 ohm resistance, and D1 is a red LED which is not connected anywhere, I believe, but maybe connected, I really don't know. And if you scroll down a little bit, you can see that U4 is a photodiode. So many things. This is so called bill of material. So pretty much, if you are a new beginner, or if you are a person, I mean, you are a beginner, and if you are a person who are exploring, who are interested to explore how electronic industry works, how design engineer work, you can little bit have a, you know, knowledge with respect to this one, exploring a circuit as well as exploring with respect to component that is listed with the Tinkercad. And it is auto generated. You need not to do anything by yourself, only you have to do the proper connection with respect to circuit here, and then click on that particular IC or maybe the component list here. You literally get everything done by software. Okay, not limited to this one. Again, I just wanted to showcase to you one more thing. Not only writing a text code here, or not only handling a 2 controller, you can handle 3 or 4, whatever number you want. Of course, there is no necessary that you need to work with hundreds of controller at a time. So probably a 2 controller you can explore and you can try by yourself. Okay, thereafter, when you change this text option to a block option, of course it will ask for some confirmation, but after that, if you change it to block option, you can literally build your code by just a drag and drop option. You can see here, by drag and drop option, you can literally create a circuit, but of course it needs a little bit different thought process and understanding. It is not recommended for the one who are interested to learn coding, because coding is always better than drag and drop option, because drag and drop option is not permanent and it is not going to give you full control over whatever you want to do. Of course, so you have to do it by yourself with a coding methodology, but still, if you want to explore by yourself, adding some drag and drop option and trying with exploring something with respect to drag and drop, of course you can give a try with respect to this one. Thereafter, I'll go back to simulation. Of course, I have shown you simulation part, so I don't think so we need to show it once again to you. Thereafter, I'll just stop this one. Now what we need to do is, once you are done with this particular circuit, you can literally share this circuit with others if they need to validate your circuit, or if you want to share this particular circuit with your friends or anybody who is learning Tinkercad for the first time. You can always click on send to option and you can download the files and send it to them. This is one option which is all about picture, like if you download this one, you will get a picture of this one. You can download this and send it to them and they can explore everything that they want. But along with that, you can share the entire circuit with respect to Fusion 360 software, which is not recommended. Of course, it is not related to electronics, it is related to 3D design, so which we are not going to do. Even if you want, you can share the electrical files in the BRD format, which is Eagle software extension format, which again not related to beginners, but still if you want you can explore this one. But I don't know what is wrong with this particular software. I'm not able to scroll down where I have a small link which I can share with my friends to access this particular circuit. I don't know what is the problem on this particular day when I'm recording this video. I'm not able to find that link. I'm not able to scroll down with respect to this small pop-up window. So please check with yourself. If you are able to find that particular link, share it with us in the comment section. I'm very happy to look into it and comment on your creative activity, or exploring anything with respect to sensors and actuators in Tinkercad. So this is how you can share your circuit with respect to someone whom you want to see that particular circuit and give you some feedback. So this is all about exploring Tinkercad and creating some circuit that is going to help you, and creating something that is innovative and other than whatever the tutorial we have covered so far. I hope you are going to do something and you are going to share your experience in Tinkercad, and I'm very excited to see your circuit as a link in comment section and give some comment back to you. If it is possible, please do share, and let's see if we can start a conversation on some design and development activity. So this is all about Tinkercad. See you again in the next particular tutorial, or maybe a next course where I'm going to talk about some other new skill which I'm going to use as an industrial skill in my career, and I'm going to share those all knowledge, practical experience with you in coming tutorial. Consider subscribing to our channel, Linked Frequency. Tune yourself to make a difference.